Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 3.1, Problem 4. This is Section 3.1, Problem 4. It says graph the linear inequality x plus y is less than or equal to 3. So to graph a linear inequality is a four-step process. Step 1 is pretend it's an equation and find 2 points that have coordinates that make the equation true. So to do step 1, to pick those 2 points, I make a little chart next to the linear inequality that I have to graph, and it has an x column and a y column, and I fill that in. So the first point, I'll start by just choosing a value of 0 for x and figuring out what y has to be. And again, you can choose other values, but 0 is really easy to work with. So if I pretend that instead of x plus y is less than or equal to 3, that I actually have x plus y equals 3, pretend that's an equals, and I put in a 0 for x, I just have y equals 3. If y is 3, you get 3 equals 3, it makes the equation true. So one point that makes this true if you pretend it's an equation is 0, 3. X is 0, y is 3. And now for a second point, I'm just going to let the y equal 3 and solve for x. And it's the same type of thing. If I'm pretending that the linear inequality is an equation instead of an inequality, and I zero the y, I just have x equals 3. So 3 for x and 0 for y is the second point that I need for step 1. So those 2 points, 0, 3, and 3, 0, make the linear inequality true if I pretend it's an equation. Step 2 is plot those 2 points on a graph, the 2 points from step 1. So 0, 3, well, let me put in the numbers. 1, 2, 3, 4, 5, 6, that's enough. 1, 2, 3, 4, 5, that's enough. 0, 3, my first point, if I start from the origin, go over 0, up 3, I wind up there. Over 0, up 3. That's 3, 0. 0, 3. 3, 0 is the other one. So starting from the origin, I go over 3, up 0. That's right there. So that's step 2. Take the 2 points from step 1, plot them on the graph. I did. Step 3 is connect the 2 points with a straight line. So I'm going to use a ruler. Put it right on those. I'll hold it. So step 3, connect the 2 points with a straight line. There it is. I use the solid line for this because I have the or equal to in my linear inequality. If I did not have the or equal to, this would be a dashed line. And the final step, step 4, determine which half of the graph I need to shade, below the line or above the line. To do that, choose a test point that's not on the line. Use 0, 0 if you can. 0, 0 is not on the line, so I can use that. So 0 for x, 0 for y, that's my test point. And put in 0 for x, 0 for y in the linear inequality that I'm graphing and see if the result's true or false. So when I put in 0 for x, 0 for y, I wind up with the statement 0 is less than or equal to 3. Well, that's true. 0 is less than or equal to 3. So my test point came from the underneath side. The result was true, so that means everything in the underneath side is shaded. And again, if I got a false result, I would shade the opposite side. So if I had chosen any point in here, like say over 5, up 5, I would have gotten a false result. I would have had 10 is less than 3, which is not true, which would still make me shade the side that I did shade.